Convert 4 complete 3/4 into decimal.
Okay.
Convert 4 complete 3/4 into decimal. So this was decimal conversion.
So it's basically 19/4.
19/4, correct. 4 4 is 16 plus 3 19. Now if denominator is 4, in that case we multiply by 25, because 25 4 is 100 in
Yeah.
denominator, and 19 times 25 we multiply, so it gives 19 5 ja 95, 5 carry, 95 9 carry, 19 2 ja 38 plus 9 47, 475 over 100, that gives us 4.75. 39/40. It is similar to previous one. In denominator there is 4, so we multiply both numerator and denominator by 25. Denominator become 25 4 ja 100 and followed by 1 0, so it becomes 1000. Denominator become 1000. Numerator 25 table we use in multiply, so 25 9 ja 225, 22 is carry, 25 3 ja 75 plus 22, that gives us 75 plus 22 97. So its answer is 0.975. This one is correct. I think next one mistake was not here. Next mistake was in complete the sequence. Complete this sequence 3.456. So in complete this sequence 3.456, 4.45, 5.458. There is 457.
Yeah, I kind of made a mistake because I kind of wrote 7 again. I was supposed to write 8 that time.
Yeah, 8 will come. 3, then 4, then 5,
Yeah,
then 6, then 7.
that's what it was.
Similarly 4 4 4 4, after decimal there is 4, then 5 4 5
Are
6.
the true and false questions correct, right?
Yeah, two. There is
True
one
and
more.
false.
There is one more question about money, paisa. So 105 paisa into rupees. Convert 105 paisa into rupees.
Yeah, I was supposed to write $1.05.
Okay.
Like $1.05.
So
1.505.
you look feel this way.
No, 05.
105 $1. Okay, one. Okay. But where is the decimal? There is not a decimal. Then
Because it is over 100 and there is only 100 cents in $1.
yeah.
So it will become $1.
But answer, how you got this answer? This rupees convert into paisa. This paisa convert into rupees. 105 paisa equal to convert into rupees. So how you got this 0.015 answer? That we know that 1 rupee is equal to 1 rupee is equal to 100 paisa. So here we divide only by 100 to convert into rupees. 105 paisa convert into rupees, we divide by 100. So 100 is 2 zeros, so it puts 2 decimals. So start from here decimal, we count 2 decimals. So 1.05 rupees will come as our answer. multiplicative inverse fraction like multiplicative inverse, like 2 over 5. What is multiplicative inverse of it? So its multiplicative inverse, we change the numerator and denominator position, so its multiplicative inverse is 5 over 2. So what is multiplicative inverse meaning? This was the
Is it
fraction.
basically just change? Is it basically just flipping the the fraction over?
Yes. So this multiplicative inverse is denominator and numerator change only, and when we multiply this multiplicative inverse with this fraction, we got the answer 1. We got final answer 1. So because 5 numerator denominator cancel, so multiplicative inverse gives the fact multiply product of multiplicative inverse and fractions 1. So this is the product of both the, this is fraction, this is multiplicative inverse. So can you try multiplicative inverse of 2 complete 1 over 3? What is multiplicative inverse of 2 complete 1 over 3?
Still be in a mixed fraction, or would it?
This is mixed fraction, 2 complete 1 over 3. Mixed fraction is there.
So will it be?
So in that case, we first convert into improper fraction.
Okay, okay, yeah. 3/7.
3 over 7. Yes, denominator become numerator and it will 2 3 is 6 plus 1, 3 over 7. So one is, now next is additive inverse. In additive inverse, we use additive inverse. We use addition. So addition, it means suppose 2 over 3 is our number. So what its additive inverse is minus 2 over 3. Only plus minus sign we change. Only plus minus sign we change. We do not switch the numerator and denominator. And multiplicative inverse, the fraction and additive inverse, their sum is always give us 0 value.
Yeah.
So now try additive inverse of some numbers. Find the additive inverse of 1 over 7. What is additive inverse of 1 over 7?
Wait, additive?
Yeah, additive. We do not flip numerator denominator.
Negative 1/7.
Correct, negative 1 over 7. Now, can you tell additive inverse of negative 2 over 3?
2/3.
Yes, positive 2/3. So it means 2/3 only. Can you say additive inverse of 5 over 6?
5/6. Wait, additive still, right?
Yeah, additive.
Okay, then -5.
Negative 5 over 6, correct. So we are making here table for additive inverse and multiplicative inverse, and we are finding the value. Here is the number and we have to find out. So in the first there is the number given, there is additive inverse, then there is multiplicative inverse. So suppose number is 6 upon 7. So can you tell additive inverse of 6 over 7?
Negative 6 over 7.
Negative 6 over 7. Can you tell multiplicative inverse?
7 over 6.
7 over 6. Similarly, 2 over 4. 2 over 3. Additive inverse.
So that is negative 2 over 3.
Negative
Then
2.
that would be 3 over 2.
Yeah. And we can say multiplicative inverse in proper fraction we convert 1 complete 1 over 6, 1 complete 1 over 2. And now can you tell additive inverse of negative 5 over 6?
5 over 6.
Yeah, 5 over 6.
And then 6 over 5.
6 over 5. Is it correct?
Yes.
Can you tell me in the multiplicative inverse we do not change the sign? The negative sign is here, so negative sign we put here also.
Oh, yeah.
And numerator is larger, so we convert into mixed fraction. Next one is number is 16 over 17. Additive inverse. Sixteen over 17. What is additive inverse of 16 over 17?
Negative 16 over 7.
And multiplicative inverse?
17 over 6. 15.
Correct, 17 over 16. Now the fraction is in mixed fraction. So 3 complete 1 over 2. What is additive inverse? And what is multiplicative inverse?
That would be negative 7 over 2.
Okay.
And the multiple would be 2 over 7.
2 over 7. When we convert this additive inverse into mixed fraction, we get negative 3 complete 1 over 2. So only this mixed fraction we write here and we convert into, we do write as it is, but sign is opposite. Now what is additive inverse of negative 1 over 4?
One quarter.
1 over 4. And what is multiplicative inverse?
Negative 4 over 1.
Negative 4 over 1. It is same as negative 4. Next is, what is next number is negative 3 complete 1 over 2. Negative 3 complete 1 over 2. Additive inverse of negative 3 over 2, 3 complete 1 over 2. 3
3
1
and
over
1/2.
3 complete 1 over 2 is,
Yeah.
and multiplicative in
And negative 7 over 2.
2 over 7.
Yeah. 2 over 7. Yeah.
Okay. So I think additive inverse and multiplicative inverse we have practiced. Next we are practicing. Can you tell 14 over 3 is which type of fraction? 41 over 3, which type of fraction is it? Forty-one over 3 is which type of fraction?
Over 3 is an improper fraction.
Yeah, this is called improper fraction. So we convert into proper by dividing. So we divide one time, then 11, 3 time, 2. So this is proper fraction. Can you know factor tree? Factor tree. Do you factor tree? Do you know?
Factor
Factor tree.
factor E.
Tree. Like plant tree.
3.
Yeah. Of given a number, here is given number is suppose 42. Factor tree of 42. Factor tree of
Factor
42.
42. Is it basically what timetable it comes in?
Yeah. Yes.
Okay, so 1 and 42.
Yes. 1 and 4.
141, 42, 2 and 21.
21. Yeah.
Then 4. Hang on. 6 and 7.
This now 21 we divide into 3 and 7. 3 7 are 21.
Okay.
So this whole is called fact.
That
This
is 6 and 7 though.
where is 6 and 7? 6 7 are 42.
I get it. Okay. So then after that, it then becomes
This is the final answer of factor tree of 42. We can write it in multiple way, like 42 is written as 6 times and 7 times. This is another method, and 6 is divided into 2, 3 and 1. 7 is as it is. So these are factor, this is also factor tree. So there is different representation of factor tree. Can you multiply 831 multiply by 103? And the method is distributive, using distributive property. In distributive property we write 103 as 100 plus 3. So inside the bracket there is how many terms? 2. So this outer number we multiply both the term individually. So first we write 100 multiply 831. Then we write this 831. Yes, 831. Then multiply by, with this second number 3. So first we get 83100. Then we get multiply by 831 with 3. We get 2000. Yeah. And now
which
we
then 12, 8, 5, 6, yeah.
I think there is 4 digits, so 8 5, yes, 8 5, third digit.
Yeah,
This
5.
becomes 6 because it gives the
Yeah. And then it becomes
no,
6.
this 93 first we write here, then 4 plus 1 5, then 2 plus 3 5, 8 5 5 9 3.
Yeah, 85593.
So in this method we use multiply of 831. Otherwise we know this method also, but we do not use this method here. Otherwise answer will be same. 3 1 ja 3, 3 3 ja 9, 3 8 24. Then put 2 cross due to 0, then 1 multiply. So it both method give the same answer, but it is a small class problem, and this is our new class method, and this property name is distributive property. So whenever you got in hundreds or in thousands, you use this method, bracket method. Can you three evaluate 3 complete 1 over 2 minus 2 complete 1 over 4 plus 1 complete 1 over 8 plus 3 over 10. If
What do you say?
this is the solve this one. 3 complete 1 over 2 minus 2 complete 1 over 4 plus 1 complete 1 over 8 plus 3 over 10.
Okay. This is basically the dispute method.
This is first we convert into improper. So here we convert into improper. It becomes 2 3 is 6 plus 1 7 over 2. It becomes 2 4 is 8 plus 1 9 over 4. Then here we convert 8 1 is 8 plus 1 9 over 8. Then 3 over 10. So we see the denominator are different. The denominator are different. So first we convert into same denominator, like so same denominator means we find the LCM of 2 4 8 and 10. So 2 4 8 and 10, how we find LCM, do you know? The LCM of 2.
I forgot.
Okay, so first we write in this table form 2 4 8 10. Then divide smallest prime number, that is 2. So it divide 1 time. 4 divide by 2 2 time. 8 divide by 2 4 time. 10 divide by 2 5 time. Now again divide by 2. So 2 divide this one written as
Is it 80?
80. Okay, just coming
Because
answer.
80 comes in all of the entire table.
I maybe it is 80. So last one is 5. So multiply.
It's because it is a 10, so
Look,
in
look,
10
look.
in 10's timetable there isn't basically any other than ending with 0.
Look, your final is last 1 1 1 1, but you multiply 2 2 ja 4 4 2 ja 8 8 5 ja 40. So 40 is the 40 is the LCM, not 80. Instead of 40 we can use 80, but there is 40 also available. So a smaller number will give us
40 doesn't come in 8 times. Oh, wait, 40 times.
8 5 8 5 ja 40.
Yeah.
So what we do here, we multiply to make it 40, multiply both numerator denominator by 20. Here both multiply by 10 to make it 40 in denominator. Here in a, denominator 8 is, therefore we multiply both by 5, numerator denominator. In 10 denominator we multiply both numerator and denominator by 4. Now we get 140 over 80, 40. Here we get 9 10 ja 90 over 40. Here we get 40, 9 5 ja 45 over 40. And in the last we get 3 4 ja 12 over 40. So this 40, not 45, there is 40. So we this 40 we write one time, and in numerator part we write 140 minus 90 plus 45 plus 12. So positive number is there in numerator 3, that we add all the three positive number. 140 plus 45 plus 12, it gave 140 plus 45 180,
180, it becomes 190.
197, 197 minus 90 over 40. 197 minus 90,
That would be 107 over 40.
107 over 40. So it convert into mixed.
And it would be, it's a, put it in mixed fraction?
Yeah.
I don't know, wait,
42 ja 80, 42 ja 80. So 27 will left.
Oh, wait,
42 ja 80, so
yeah.
27 left. So to complete for 27 or 40 is the answer.
What's the answer?
To complete 27 over 40.
Okay.
Orally I am asking. First is, a line is a collection of dash. A line is a collection of dash.
The line is collection of,
A line is a collection of dash. A line is a collection of dash.
like, what is this referring to?
A line is a collection of dash. So what here we can fill, there is a empty space. A line is a collection of,
So, are there any, like, options?
so this is geometry, one geometry word we can fill here, like line segment, like ray, point, circle. So here is the answer, point, because point is the smallest in all of these in geometry, and in a line there is a collection of many points. So there are, in a line segment, a small line segment, there are infinite points. The size of point is very 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 small, but we draw in a particular, in a specific manner to represent point, but point is very small. So infinite point is available in a small line segment, also in large line segment, as well as line. So line is a collection of many points. So many points, it means uncountable points is available in the line. Now second fill in the blanks question is, a right angle measures, RT means right, a right angle measures dash. A right angle,
I can't, what's after the measure? Yeah.
a right
Angle
measure, a right angle
measures.
dash.
Does
What
that say set?
what is the measure of right angle? Look,
90 degrees.
90 degree, correct. No need of option. Okay, 90 degrees is called right angle.
It's just because I couldn't read the right word.
Next is a dash as starting point and end point. A dash has starting point and end point. A dash is has a starting point and end point.
Number line?
It is the line segment.
Oh,
Line segment.
but it's still a line.
Line has arrow on both sides,
Oh yeah.
and line segment has only points on starting as well as in ending. Line segment.
Isn't line segment also used for fraction, like the fraction line?
Line segment is a fraction of line, and line segment we draw with using ruler, 3 centimeter, 5 centimeter.
Yeah.
So line segment has starting point and ending point. Line has no ending point on the both direction, and in one direction ending point is ray. Only one direction there is ending point. This is called ray, ray. So line segment, ray. These are three different things. Next, fill in the blanks is an acute angle is dash, then a right angle. An acute angle is a dash, then a right angle. An acute angle is a dash, then a right angle.
Acute angle is less than a right angle.
Yes, less than is correct. So acute means less than 90 degree. Next is sum of two right angle is. Sum of two right angle is. Sum of two right angle is. What is the sum of two right angle?
The number? The degrees?
Yes, in degrees. How much?
That is 180 degrees.
Yeah, correct. 90 plus 90, 180
So it
degree.
basically becomes a straight line.
Yeah, this is also called a straight line, straight angle. Next is an angle whose measure is 120 degree is an dash angle. An angle whose measure is 120 degree is a dash angle.
Then obtuse angle, I think?
Yes, obtuse angle, correct. So greater than 90 is there, so obtuse angle lesser than 180 degree is considered as obtuse angle. And instead of there is 120 degree, if the value is 20 degree only, then what it become? An angle whose measure is 20 degree is an dash angle.
It becomes an acute.
Acute, correct. So in that case it is lesser than 90, so it is acute angle. So do you know parallel line? parallel line. Parallel line. Do you?
Parallel line, yeah. They're opposite each other and they never meet.
Yes. They travel in both. They never meet in both direction when we extend both the line.
So like say for like a rhombus or a parallelogram,
Yeah.
they're like even a square and a rectangle, all of those are parallelograms because they are parallel sides and they don't meet.
Yeah. Correct. So correct. Parallel line. So in our copies in our railway line, they all are parallel. So parallel line have fixed distance between these two lines. Everywhere they have fixed distance. Their distances remain constant throughout their line, parallel line. Now, do you know perpendicular line?
But
Perpendicular line.
like how? If you can just
You
I might remember. If
this is
you
the
can just
line. This is one line, and on this right angle means 90 degree. This is another line. So both line are perpendicular to each other. 90-degree angle. Another name is perpendicular.
okay.
So
Oh yeah.
two lines when they intersect at right angle, they form perpendicular line.
Yeah.
So whenever we cross our road, highway, we perpendicular cross the road. So walking to cross the road on zebra line always perpendicular on the road. So do you have zebra line near your school?
Zebra line.
On the road there is
Yeah.
for pedestrian they use zebra
Yep.
line
Yep.
to stop the traffic so that passenger the
So that they
pedestrian.
can stop for the children. Yeah.
Okay. So I think your homework is enough today for today.